Good morning, everyone. Please take a seat. My name is Fabian Ganden. I'm the General Chair. As you all know, the General Chair of the conference is the less useful person. The only thing the General Chair has to do is to find the greatest team to do the conference. And it's really a great pleasure for me to welcome you today here and also to present you this team who has been working very hard in the past 2 years to make this conference happen. So in the next 25 minutes, we're going to be covering the local activity and local organization aspect. We're going to be giving the SWISA Awards. Then we'll have an overview of the program of the conference and starting with the research track, and then an overview of the other tracks. So please, the first thing I would like to ask from you is to warmly welcome on stage the two representatives of the local team, Jill and Jing.
Nomai, Hirame Ki Ati Aurora. Greeting to you all. On behalf of the local team, we'd like to welcome to New Zealand, the land of long white clouds. This year, we have received 308 valid registrations across 40 countries, and with a majority of 50% coming from Europe. The organizing of the conference received support both locally and internationally. We have local organizations such as Tourist New Zealand, Auckland Conventional Bureau, University of Auckland, to name a few. Most importantly, we received financial support from our sponsors such as IBM Research, MetaFacts, Google, GE Global, Data World, AI General, and Springer, University of Auckland, VideoLecture.net, who is filming us at the back right now. Thank you very much. As the role of the local chair, I would like to remind you of a few housekeeping informations. I'll keep this very brief because there's quite a lot of items to go through. If you have luggage, we have storage at the registration desk. Power extensions back and front of the room. Remote representation, please let us know early so we can arrange the facilities. Lunch will be served at 12:40 p.m. in level 1 foyer. If you are presenting a paper, because we have all the presentations recorded, so remember to submit the signed consent form and also put your presentation on the USB drive so our video recording crew can do post-processing, put the presentation together with you on the final file. Sky Tower ticket is in the back of your name tag, so you can visit Sky Tower anytime during your stay in Auckland. Please remember to wear your name tag all the time, so our local team can identify you as one of the delegates of the conference. This is very important for welcome receptions and conference dinners. Discernment Glen room is on 3rd floor. We have been asking, lots of people asking where this room is. DC lunch today will be served there. A job fair is scheduled on the last day of the conference from 12:40 to 2 p.m. at the level 1 foyer. Interested parties such as industrial representatives and students are welcome and encouraged to attend the session. Some of the company already request exhibition space for that job fair. If you haven't done that and would like to have one, please approach the reception desk, registration desk. Sizing and excursion information are provided by exclusive tools. For bookings, you can approach the registration desk. Anne Marine will be sitting there next to the reception area on Monday and Tuesdays. Welcome reception, which is today, starts at 6 p.m. to 10 p.m. And the location is the OGG level 0 foyer, was on this level. If you have any question or any queries, please don't hesitate to contact the local team at the registration desk. Last but not the least, the conference dinner is happening at Sky City tomorrow night, 7 p.m. Drinks and beer testing will be at 6:30 outside the function room. We have arranged bus transportation from the conference venue to the Sky City at 6 p.m. If you would like to require extra ticket for the dinner, please approach the registration desk. Finally, we invite you to experience everything magical that New Zealand has to offer. Thank you.
Thank you again. Organizing a conference and making it run is a really hard and time-consuming task, so thank you very much for all the events you've been doing in the past years. Now it's my great pleasure to welcome on stage Professor Ian O'Rourke as the president of SWISA. He will present the association and the different awards.
Thanks. I'll probably just use that. Welcome, everyone. If, like me, you've come from Europe, thanks for making the long trip. I'm sure you'll find it's very worthwhile. Beautiful conference laid on by our fabulous hosts here. So SWISA, as I guess most of you know, is the kind of steering organization for the conference, and our main job is organizing the conference from year to year, selecting venues and making sure that we have suitable financial arrangements in place. One thing to remind you about is the town hall meeting, which is going to take place on Tuesday, as you can see on the slide. This is usually a really interesting meeting, and we get a lot out of that, getting feedback from you guys about what was good, what wasn't so good, great new ideas for future things that we could do to improve the conference. So please come to that and participate there. Okay, so then the other thing that SWISA does is that they are responsible for a couple of different awards, and it's my great pleasure to announce the winners and to award them certificates. And as we'll see in a moment, not at this exact moment, but at some time in the near future, honestly, they'll also receive substantial cash prizes. So the first of these is the Distinguished Dissertation Award, and this recognizes an outstanding thesis from a student working in the semantic web area. I already mentioned the certificate and the substantial cash prize of €1,000. And the other nice thing that winners of this prize get is travel costs and free registration at ISWC, which is worth quite a lot also. So please do think about whether or not you or one of your students might be a future winner of this award, and consider persuading your supervisor to nominate you, or if you are a supervisor of students, nominate people, because actually, believe it or not, with this amazing prize, it's quite hard to get good nominations. So remember to nominate next year. Okay, so without further ado, I will announce the winner of this award, which is Peter Ristowski. Is Peter here? Yes, a round of applause for Peter. And I think somewhere in here I have the certificate for Peter. Let me just make sure I'm giving you the right one. So, certificates, oh, there you go, it's stuck to the back of those ones. Excellent. Peter, congratulations. Thank you. Okay, great. And the second award that we present is the SWISA 10-Year Award, and as the name suggests, and as you can see from what it says on the slide, this is recognizing work that's had an impact 10 years after it was published at ISWC. So this is quite nice because we can really see then, you know, what happened to the paper and how it influenced the research that we're all still doing. And again, the winners get a certificate and a substantial cash prize, $1,000 in this case. I'm never quite sure why the dissertation gets a Euro prize and the 10-year award gets a dollar prize, but that's just the way it is. So, okay, and the big reveal, the winners for this. Actually, there were 2 winners. We couldn't separate these 2 great papers, so we decided to split the prize this year. And as you can see, the winners are, well, I won't try to read out all the names. I'll just go with the Christian names because I can pronounce them. Olaf Christian and Johann Christoph, and Julius Christian, Martin, and Georgi for these 2 great papers. So do we have any or all of those people? Oh, Olaf. Make sure I'm giving you the right. Congratulations for the great job. Okay, awesome. And there's a bunch of certificates in there for your co-authors, right? Okay.
Actually, none of them. I'm a little bit too young to receive the award, but Christian asked me to receive the award instead.
Okay, well, I guess you can
Come on this side.
Is it
Still a photo already?
Yeah, still. Oh, yeah, why not? Okay, good. Back to Fabienne. Thank you.
Thank you, Ian. Another important activity in our community is the summer school, and I wanted to take that opportunity, thanks to Valentina and Harald, to mention this summer school because a number of senior researchers now in our community went through that summer school and remember that as a very important point in their career. I believe Valentina already spammed all the coffee breaks with the flyers, so please grab one. The next one is in July in Bertinoro, which is really a good place in Italy. So again, consider, if you are a supervisor, consider pushing your student to attend such summer school. And if you are a student, consider pushing your supervisor to make you attend. Now, I have the great pleasure to welcome on stage our 2 program chairs. As you know, they are key in ensuring the quality of the research papers that are presented. And today, I'm really happy to welcome on stage Chiara and Olaf, who did a really great job.
So, very warm welcome from our side too. It was a great pleasure to do this work. And we have put together a really great program for which, for the research track, we have received 194 papers. I have a few stats for you about these. This is the number of authors per country for these papers. So you see that the country that kind of contributed most to these submissions was China. Then we had Germany, United States, United Kingdom, and so on. Another very interesting stat is the number of submissions per topic. And here you see that the by far most important topic that people submitted most papers for was the database information retrieval, information extraction track. And then we had search, query integration, knowledge graphs and deep semantics, machine learning and knowledge representation, and reasoning on the web were kind of the next most important submissions. And then also I listed the topics that are the ones for which we have received the fewest submission. So these are topics that I think are still important for the community, and we still and you should also still continue working on these. With all of these submissions, we reviewed them together with a team of senior program committee members and a huge amount of program committee members. Overall, these produced like 738 reviews, and almost all the submissions received at least 4 reviews, some of them even 5. This is the list of the senior program committee members. So we had 26 people who really helped us a lot with putting together this program. So if any of you on the list, please stand up so that we can give you a big round of applause. Do we have anybody in the room? And then also we have the list of people who did the reviews for the research track. These are 270 people. I also want you to get up, as well as everybody who has reviewed for the conference. Not only for the research track, please also, if you reviewed for the in-use, for the resource, for the industry track, for the doctoral consortium, posters, papers, even for workshops, please get up if you reviewed for the conference.
you. And while the overall quality of the PC members was pretty good, we had outstanding people. So we want to mention them and to thank them in a special way. Since most of them are not here, actually, we want award people on stage. We will take care of delivering certificates after the opening. So, first of all, for the senior people, we had an outstanding winner. There was no doubt about it. And the winner is Katia Jose from Aalborg University. So, thank you, Katia. And we also had a very good runner-up, and he was Matteo Palmonari from University of Milano Bicocca. Then, for the PC list, we weren't able to single out a unique winner. Indeed, we have two, and it's Giuseppe Pirò from Sapienza University of Rome and Dagmar Groman from TU's Dresden. Thank you. Even here, there were people also standing out as good runner-ups. They were Eva Blomqvist, Aidan Hogan, and Peter Pater-Schneider. Let's thank them. And besides the winners, since we had very good people, we wanted also to acknowledge the ones who received at least one mention for the best PC member. So they are basically marked on the PC list in the website with a star, and if you can go there, you can really see the people who did an excellent job. So thank you, everybody. Now, with this great team, we selected then 42 papers. They are here for you to listen to, with an acceptance rate of almost 22%. Now, to conclude, the PC is not important only for the research track. As Olaf was mentioning, it's really crucial for the quality of the conference, and therefore we are mentioning here also the best reviewers for another track, for the news track. To save time, we will present them. But Is it? Yeah, they are here, and then I will go back. So they are Matteo Palmonari from University Milano Bicocca, again. So good people are good over everywhere, basically. And then the runners-up here were Rafael Gonçalves, Armin Haller, Vanessa Lopez, and Matthaus Slock. So thank you, everybody. Now, an important reminder for the presenters: see your session chairs before your session, so be sure to be there on time. There are 20-minute slots for mostly everything, 15 minutes for the presentations and 5 minutes for the question and answer. Please keep on time, and also the session chairs help people to be on time, and also video lectures are recording the talks, so don't forget to fill your forms and the consent. So, Fabienne.
Okay. So now I'm going to take a few minutes to acknowledge all the other chairs that have been working with us, 26 of them in total, to make happen all the tracks we have at the conference. Starting with the new track that was introduced this year, thanks to Alejandra and Michael. It is the reproducibility track chair. They will be talking more about it at the closing ceremony. But you can already see in the program that some of the papers are marked reproduced this year. Actually, 7 of them. These are papers from the research track who had accepted to do that competition, that part, and to work on being reproduced by others. We want to push that aspect to show that it participates to the quality of our research results. 3 others are still in the process of being reproduced right now. We had, in the in-use tracks, thanks to Isabel and Aidan, we had 25 submissions and 11 papers accepted. Maria and Wojtek, they worked on the resource track, which was extremely successful, 64 submissions, 21 accepted. And Annalisa and Christoph were in charge of the industry track with 24 submissions and 16 accepted. We have a journal track this year. The idea is to submit an abstract corresponding to a paper that was published in the journal but not presented in the conference. 24 abstracts were presented, 13 have been selected for that track. Sophia and Heideka worked to select the workshop and tutorial that happened the 2 previous days. That was a really tough work this year. and they did a great job, really. None of them can be here today. Posters and demo were handled by Marie-Carmen and Gong. We had 55 submissions for posters, 39 are presenting, and 42 demo submission, 37 are presented. And we also have a full track challenge running on. It's going to be on Wednesday, if I remember well, the track, and 2 challenges are going to be presented there. The doctoral consortium ran yesterday. 16 PhD students submitted to that consortium, 13 presented. We, thanks to Oshani and Bruce, we ran the student coordination track, including the grants, for instance, for traveling. So 68 students applied, and 18 grants have been funded by SWISA and NSF. The Minute of Madness is going to happen today. I'll come back to that a bit later. We currently have 45, maybe more, presentation. And Maria and Abby, they ran the outrageous ID track, and 2 papers have been accepted. They're going to be presented tomorrow afternoon. I'd like to thank GA and Maxim for their work on the proceedings. We are still talking with Springer to understand why the link is not working properly. Mariabel and Andrea have been working on the metadata, and they are published, and you can connect and sparkle them if you want. Valentina, Fuhad, and Asha have been our publicity chair and web chair. They did a great job at advertising and keeping the website up to date. And a big thanks also to our sponsor chair, who helped us balance the budget. Lai, Cedric, and Opti, they did a great job at securing the sponsorship. Thank you again. A few things about the program. Today, we're starting at 9. Tomorrow, you'll be a bit more tired, so we're starting at 9:20. And after the gala, you'll really be tired, so we're starting at 10. The Minute of Madness, following some feedback from previous edition, we decided to split it in 2, because it's hard to keep the madness for 2 hours. So we're going to have 2 minutes of 2 sessions of 1 hour to keep it as lively as possible. Welcome reception and posters and demo tonight. Do not miss it. Tomorrow we have the mentoring lunch. So remember, ISWC is on the 3rd floor. The food will be served there, so the student who registered and the mentor should go directly to the room. We have a plenary town hall meeting, plenary because all of you should participate to the life of our community, and it's going to happen tomorrow afternoon, beginning, and it will be run by Ian and Suiza and the local chair. If you look at the program, you will see the spotlight paper. Spotlight paper mean they are either nominated for best paper or they have been polarizing the reviewer, so they're going to give great discussion. It's always an indication of an interesting paper to listen to. And the new thing is that you also have the reproduced one if you want to have a look at them. For posters and demo, we're going to use Slido for voting, and the code is ISWC 19 poster and ISWC 19 demo. And you will be able to vote until midnight tonight, local time. Finally, we have a great slate of keynotes and panelists. Dougal, today we'll talk about the business technology disruptor of the future. Jérôme, tomorrow we'll make a plea for knowledge, and he will be followed by a panel on how much semantic goes along, how long away, The panelists who will join Jérôme are James, Valentina, and Annika. And finally, on Wednesday, Melanie is going to talk about extracting knowledge from the data deluge to reveal the mysteries of the universe. And without further ado, I would like to hand the mic to Jill to introduce our first keynote speaker, and I thank you for your attention.
This is like handing the baton over. So, tēnā koutou, tēnā koutou, tēnā koutou katoa. I'd like to welcome you all to Auckland, and particularly to the University of Auckland. It's my great pleasure to introduce our keynote speaker, Dougal Watt. Dougal's got a very interesting background and a variety of experience, and I'm sure that will come through in his talk. Currently, Dougal's the Director and CTO of Meaningful Technology, a platform-as-a-service business predicated on the use of semantic web and graph technologies, and the company is here in New Zealand. Prior to this, He was the Chief Technologist of IBM New Zealand and co-chair for New Zealand on the Square Kilometre Array project, the industry consortium. In this talk today, he'll describe how semantics can help solve some of the problems that people are facing in industry, and I'm sure that with his abstract thinking, he will bring some very... I find that he gives very clear direction. So Dougal, welcome, and I'm looking forward to the insights from your talk today.
Turn this thing on. Good morning. Thank you, Jill, for that lovely introduction. Welcome everybody to Auckland and to Auckland University, and many thanks to the program committee for selecting me to give this keynote. It's actually a real honour to be here today. Thank you. As Jill mentioned, I'm the Technology Director, CTO for a company called Meaningful Technology. And we're actually using semantics in anger, as they say, to help businesses survive the tsunami of change that's happening in the business community at the moment. It's hard to overstate actually how much business is changing. You probably see it every day with retail shops being closed, everything going online. It's a lot of disruption. But before I get into that, I'd just like to tell you a little bit about my background, and it's more as a way of leading into what that change is about and how technology can help to address that change, and really why I believe semantics is actually the best way to deal with it. So, although I actually have a 26-year career in technology, I come from a very non-traditional background for a technologist. I studied chemistry and psychology here at Auckland University, and my master's degree is in social psychology. I actually studied violent men. Social psychology is about how people fit in a social context and how that influences their psychology and the psychology of others. So it's a pretty unusual background for a technologist. Bizarrely, when I worked at IBM, just shortly before I left, I discovered there were about 8 other psychologists working in New Zealand, so that was weird, very unusual. But what really most interested me in psychology is actually how we construct meaning, how we share that meaning and communicate it with others. And I'd like to illustrate that through a parable. In case you don't know, that's this Greek letter psi for psychology. So this parable, the parable of the table. So it might seem a really trivial thing to talk about if you're an ontologist, and it kind of is, but I really like it because it's actually the origin story of how my company chose its name. We sat around a table and we talked about what we would call our company if we're based on semantics. But as a psychologist, if I put that hat on, it's actually a really, really interesting parable to work through. It requires a really large number of different disciplines out of psychology. Psychology is a very big field now. You need all of these things to come together to explain how we all construct meaning and share that word table. So the parable, it goes like this. What has to happen for us as humans to collectively agree on the definition of a table? So it's a slightly different question to an ontologist would ask. So we can ask quite a lot of questions about tables. So how flat does it have to be? Generally they're pretty flat. How many legs does it have? What colour is it? What about cantilevered surfaces? Cool. There's a couple that are cantilevered there. I'll just hold that. Here we go. Do we allow cantilevered tables? And then we have other questions too, which psychologists are really interested in. Why is table gendered in some languages, whereas English doesn't really have genders for nouns? It's quite an interesting question. When you actually study that kind of question in psychology, you start to pull in all these different disciplines. You need cognitive psychology, social psychology, discourse analysis, visual perception, and so forth. So there's a lot that you have to bring to bear. It's a really complex issue. But to me, the super interesting thing is that it actually ends up in a graph-like brain structure. So we all build these natural neural networks in our head, and some of them... Is it too loud? But let's... Okay, cool. Oh, okay. Cool. That's better. So we end up with these graph-like structures and often thousands or even tens of thousands of connections, which is a little bit different to traditional technology graphs. So that actually lets us communicate these shared concepts. We also know from studying brain structure at a very detailed level that some of these representations are actually very, very similar between human brains. So in a very literal sense, you are physically changing your brain structure and communicating a shared concept. It's quite a cool idea. So when we start down these ontological questions, they're kind of rabbit holes for psychologists, but they're really interesting ones. But one of the really great things about going down those rabbit holes as a psychologist is it's a very holistic discipline. So it forces you to think about all of those different parts of psychology that bring to bear on a simple thing like the parable of the table. Turns out, I've found that perspective, that holistic psychological perspective, is super useful when it comes to the tech industry, and I'll come into that in a sec. So before we get to business transformation, I'll make a small detour into taxonomy, which I find always interesting. It's not the kind of taxonomy we'd traditionally have at a conference like this. So that's a picture of my father. He's now deceased, and he was an entomologist, so he studied insects. He particularly liked beetles. He was very well known, but I didn't really understand that he was so well known until later in life. So he was really instrumental in setting up the Cromwell-Schaefer Beetle Nature Reserve. That's the first natural reserve in the world dedicated to an invertebrate, to an insect, in the South Island of New Zealand. I never actually understood what he did when I was a child. You don't really kind of know that sort of thing. I was too young. But I actually later came to understand that what he was studying actually had a purpose, and it fit within a much wider view than my father would traditionally work within. You know, we all know that insects are really critical to ecology and specifically to forests as well. You know, bees provide pollination services. About a third of our food comes from pollination from bees. Very, very important. Insects are super critical in forest ecosystems, and recent research shows that if we're going to do anything about global warming, probably the quickest thing we can do is plant a colossal number of trees. So, and that might be possibly one of the best and quickest and cheapest ways to prevent runaway global warming. So understanding the place of the very small, even in a taxonomic sort of sense, and its place in the very big is crucially important for us as a culture and a society. If you look at that macro level and the micro of flora and fauna, you get to see how the whole thing works as a system, what doesn't work, and how you can actually improve the health of that ecosystem. Now, we don't normally talk about it like this, but that's actually true in business technology as well. If you take that historic and also a holistic and historic perspective, I'm going to sort of shortly show that the health of the tech ecosystem in business is actually very poor. And it's actually not getting any better fundamentally. And a bit surprising, I think, is that most technologists who practice their craft in business today, they don't actually think about it in those terms. They don't think like that. They don't understand that that's a problem, that there's a big problem. So I'd like to take you shortly on a tour through some of that diversity of the business tech ecosystem and its health. And I'm trying to show, I think, hopefully I make my case that it actually desperately needs semantics to try and improve the health of that ecosystem. Because it's a semantic conference to start, I thought I'd create this slightly tongue-in-cheek take on the semantic layer cake, but I'm reimagining it through the world of business computing ecology. So when I did this, what really stood out to me is how diverse that ecosystem actually is. There's a lot of stuff happening in business computing. If you try to map them across, some things don't map. The other thing that is really interesting is that there's really no standardized data interchange, and there's no standardized taxonomic or ontological standards, actually. None of those exist as standards, so we don't have standardized ways of sharing and computing shared meaning in the business community. There's things like UML, but it's not, doesn't cross the bound into proper computability, and it's got nothing on OWL. So we have a very, very diverse landscape. So let's just jump a little bit deeper into that. To really appreciate that ecology, you actually need to look at management theory, and this is why it's business and technology sort of interact very strongly. You also need a bit of psychology, which is good for me. Much of the history of computing can be traced back to this guy here. This is Frederick Taylor, who invented Taylorism at the turn of last century. So scientific management theory, time and motion studies, looking at the processes that go into making things and how you can improve this incremental step and so forth. That led to a very strong drive to document in excruciating detail business processes in business, workflows and so forth. And that focus actually survived. I mean, Frederick Taylor, his popularity peaked in about the 30s, I think, but that survived actually well into the 90s, the late 1990s, in the technology community. And you can see the effects of that today. There's still a really large market for technology solutions, software that manages processes. In fact, the other day in my LinkedIn profile, in my feed, I saw somebody, I can't remember who it was, had built this radical new platform for business process modelling. So it's still undergone today. It's quite a complicated thing. On the left there is an architecture from the National Institutes of Health, how they think about process modelling. Really complicated, hopefully you can see that. Workflow rules, logging, etc., a whole lot of tools and automation, business process engines and so forth. So, as I said, this is still a very current way of thinking, even though Taylorism's got dead and buried in theory. The natural question you ask is, if I'm going to create these process flows and look at them, I have to do something with them. And we're a tool-using species. We create tools to do things. So the question is, how am I going to automate these manual steps? And that's given rise to what we call application-centric thinking. This has persisted a really long time, and it doesn't show any signs of going away. On the right-hand side there, you can see an example of what happens with application-centric thinking. So you package discrete sets of processes in applications. You end up with this proliferation of technology. So there's a business with 2 enterprise resource planning systems, a CRM to manage customer data, a whole bunch of other apps, and it just keeps on going and going and going. And you can end up in companies where you have over 1,000 applications or more, which is a really highly complicated set of infrastructure. Now that kind of seems rational and sensible on the surface. We need tools to manage these things. There are even methodologies and various tool chains to support doing this, and there's a whole informatics, information systems approach even taught at universities and around thinking in that particular way, managing those, treating them as an asset, managing them through an asset life cycle. There's a whole bunch of stuff that we do as an industry around that, and it is important. But you have to ask yourself, if we're going to be ontological a bit, how does the business computing industry specifically think about how they go about designing and managing those information systems? I started researching this around 2008 as part of some work I was doing in creating intellectual property at IBM around this issue. And these are a couple of definitions here. It turns out that I'll switch that. So it kind of begs the question, actually, if you're going to manage this stuff, what actually are you managing? What definitions do you have to think about information systems? The top one is a definition of information management from Wikipedia. It's about the best I could find. What struck me in 2008 is we have all these tools and we talk about managing information, and no one has actually really defined what managing information is. And if we go further down a rabbit hole, actually, what is this information that we are managing? And in industry, nobody had ever defined what that was. This is a really bizarre thing to think because it's really super important to know what information actually is. If you can't sort of manage something if you can't put bounds around it. We talk a lot about information architecture and data architecture in industry, and then when you delve into those definitions again, you find things like this. This is the ISO architecture standard 42010. It's a circular description, so information's got knowledge and so forth. That's actually conflating information, data and knowledge all in one definition of information. So the more you delve into this, the essence of the meaning of these things in industry, the more diffuse it becomes and the more undefined and the harder it is to pin down, which is a slight worry. In industry, we also place a really, really huge amount of emphasis on the practical application of that kind of theoretical question. So it's not theory for its own sake, it's how we turn it into something actionable. And that's often codified in these formal frameworks, and you see 2 up here. And I've actually built these frameworks for IBM. They are really important. So that on the left is the current version of TOGAF. TOGAF is the open group, very important. It's the only way you can be certified as an architect formally around the world. I'm certified in 2 disciplines through TOGAF. That's their architecture framework, how you go about creating comprehensive, extensible, large-scale architectures to manage that mess of chaos with all of those applications. And if you look at that, it actually has information systems architecture and it doesn't have information architecture, it's got data architecture. All information and data is subservient to an application in that worldview. So the philosophy of that is that information or knowledge does not exist in its own right. It is bound to an application every time. On the right, that's from OpenMic, which is it's an open-sourced consulting framework. And it's got some really good definitions for some of these terms. Recently they updated it, probably the best definitions I've actually seen. But again, when you drill down to it, they talk about the importance of developing information. There's nothing there. They don't even say how you develop information. So, big gap. So how did that confusion come about? That's obviously a pretty confused worldview. If we take a historic view and we look at how we've managed information over the ages, we can see this sort of progression. So this is just something I have lectured about in the past. There's about 6 ages of how we as a species manage information. Pre-literate, literate, invention of the alphabet, the printing press, modern computing era, that's Claude Shannon, his 48 paper. The web era, that's Tim Berners-Lee's next cube there. And then what I call the the age of context, probably starting around 2001, the semantic web. And what I've done there is I've put some representative images. And I'd like to propose that we call this group the Gang of 3, because I don't see why object orientation should have their own gang with the Gang of 4, and we don't get our own gang, so Gang of 3. I could put lots of people in here, but you have to start somewhere. What interests me is the modern computing era, and what really distinguished that is it's the first time that closed world hypothesis came to dominate in terms of how thinking about information. It was also an era where, and that had to happen because resources were so tight in early computers. Compute, CPU, storage, RAM, everything was just so expensive and so constrained. That actually continued pretty much all the way up until the mid-90s. I well remember a colleague actually buying the first Dell computers for a bank here, and he was saying and that was mid-90s, and the price just dropped through the floor. And that was the first time that the cost of compute really started to drop massively. I haven't shown it here, but you could also put a psychological overlay on that in terms of how people think. But what I find really interesting is that the things that were developed in that resource-constrained era kind of take their mindset, the way that you go about building them and thinking about them. You take a mindset from resource constraints. How do I make something work with nothing? And it's a really, really hard job to make really good code that works with very few constraints. But also, I think that until relatively recently as well, if we were to be psychological about this, the type of people that cohere around the business computing industry, they tend to not have a holistic mindset. They have a solution-oriented mindset. And the problem with that is that you tend to solve in a very expedient way for now. You don't solve for the general. You don't take those learnings out from solving for the general case and applying it to other general cases. You are very much bound to the now moment and solving something in an expeditious way. So I would actually argue that, it's changed a little bit now. We have a lot more diverse range of people coming into the computing field, but generally the people writing software solutions that hit the needs of the business world have that more non-holistic, specialist, expeditious kind of way of thinking and creating solutions. Arguably, actually, I think the whole technology sector is still mired in that way of thinking. I mentioned TOGAF before. I actually did a whole bunch of work with the TOGAF group. I left it about 3 years ago, so it might have changed, but trying to get some of the knowledge constructs, semantic thinking, information-centric thinking into the TOGAF architecture framework, and that really met with pretty strong resistance to actually even breaking information out and thinking of it as something that is not bound to an application. So that's still a very pervasive mindset. So given that mindset and that application-centric thinking, that process-centric thinking, it's actually quite reasonable to ask, well, so what? Because, we're all using technology, it all works for us, business doesn't tip over, so what? There's a lot of technology that's in use in business. It seems to work pretty well. Lots of projects are happening all the time. A lot of money being spent, I think it's about 3.8 trillion US a year on technology spending globally. So why should we even consider rethinking this? Turns out there's a huge body of literature in the business community about failure. And it's actually very, very scandalous when you really delve into it. So there is basically a colossal amount of waste in the technology industry. So the top one there is from the Standish Group Chaos Report. They've been doing that for a long, long time, over a decade. It basically shows that anything from, up to 60 to 80% of all projects fail. And the definition of failure is a little bit vague, but failure can be stopped before it gets anywhere. It can be never meets a certain large percentage of majority of requirements and so forth, or falls out of use really quickly. It has improved slightly with the advent of Agile. So that's from Scott Ambler, who's a great guy, his Disciplined Agile Consortium. He's showing that actually when you adopt Agile practices, you can shift the dial measurably. But I would actually argue that that shifts the dial and improves project delivery, but it doesn't improve enterprise-level problems. It actually lays down problems for the future, because you're actually, again, thinking expeditiously about, I will deliver this project. Yes, I will deliver it more successfully, but in aggregate, you are still actually adding to that application-centric problem. And I'll talk about this tomorrow in a separate session, but analytics is even worse. It hasn't improved with Agile, and roughly 80% of all analytics projects completely fail at some level. So it's a very, very serious problem. It's not that our industry doesn't know about this. Business knows that this is going on, but we don't like to talk about it. And business technology vendors sure as hell don't like to talk about it. So given that this is happening all the time, you can actually look and see, well, how has the technology community tried to improve the situation? We can actually really briefly look at some of these solutions that have arisen from an information or information systems perspective. These are just representative. There's a lot of other noise around the edges, but I'll just really quickly go through these. So relational databases was, they're actually massively useful, but conceiving of, people still think this, that you just need more and more databases to solve a problem. But there's a lot of issues. Interoperability, they can be very costly. Scaling very quickly hits a wall, depending if you want to horizontally scale or if you want to do lots of joins. They always give rise to data silos, and they have such limited semantics. I actually well remember once doing a piece of information architecture for New Zealand's largest company. They had SAP as its ERP, and we printed out part of the data model, and it was A0 sheets of paper on a boardroom table, and we couldn't understand the semantics of the database, and we were going, why is this GZ underscore something as the table name? And then we realised it's because it's a German software company, and they were German acronyms, and so we gave up. But they fundamentally lead to a proliferation of complexity, both in terms of table structures, columns on those tables, and the code that's necessary to manage it. And there's some numbers on this, but it leads to horrendous proliferation. Then ERP came along, so instead of having ERP's enterprise resource planning, instead of having these little vertical applications, you munge them all together, make a big product. Yep, you're done, that's great. It worked for a little while, but these things have become bloated behemoths, massive feature creep, incredibly complicated products. Databases underneath these things are just astonishingly large. They almost always lead to failures of implementation, despite what the vendors say, and they are just colossally hard to integrate with. Some of these things have improved, and there's a movement now called postmodern ERP. We're actually doing work with clients on that, and it's a way of boxing this thing and treating it in a different way. It seems to help, but these things fundamentally haven't solved this application-centric problem. In fact, they add to it because the vendors want you to just use their application and then all the stuff around the edge that they sell. Enterprise data modeling came along. That was a big thing coming into the 2000s and a bit after the 2000s. The problem with that is that it quickly got a reputation as having an ivory tower syndrome. There was a massive skill mismatch in terms of who created it and who would consume it. So consumption of the model became really problematic. They had massively long time frames to build these things. And they suffered from the whole round-trip modelling problem that if you make a change at a conceptual level, you have to run all the way through the conceptual, logical, physical, into the delivery and implementation in a system, and then it just broke if there was a change, because you can't round-trip all of that in any kind of reasonable time frame with automation. And they just became massively complicated because actually they went back to the relational and the ERP, and they pulled through the inherent complexity of those models anyway, without doing any kind of sort of ontological analysis of what really mattered. Then there was SOA, service-oriented architecture. That seemed in the mid to late 2000s as being a really good solution. This is IBM's first version of their service-oriented architecture, and it's pretty hard to see, it's slightly fuzzy, but the thing that's actually missing in there, which I criticise this as the biggest problem with it, is it missed information. So it was all process-centric. So it was all about, here's a process, model that to death, and then we'll build an application for it. And IBM did a lot of work. We all got trained in it. We all got shipped off to Sydney for training, and it was quite tedious. A bunch of people said this isn't going to work because you've missed out information. And IBM chugged along for a long time, and eventually there was a very high failure rate in these projects, and they put information in that started to work better. But not just IBM, other vendors have this problem. The problem with it is, it's too complicated. The technology stack, the time to build on it was quite high. It actually ended up just resulting in a whole lot of point-to-point integration because culturally and psychologically, people did not want to cohere around a common model. And this is another problem with the enterprise data modelling and SOA, is by and large, and this might be surprising, but our industry in the business world has walked away from data modelling. Completely walked away from it. And I saw this at IBM. We used to sell data modelling tools, some fantastically great tools. You could round-trip conceptual and logical, but not physical. But you could do some really cool things with these things. IBM sold those tools because they could not make money. People wouldn't buy them anymore. You might buy off the shelf a whole bunch of prepackaged models, mostly for data warehousing, and put them into your data warehouse. But industry walked away from data modelling, which is quite a scary thought. I see this trying to hire people today. People come in, they have no experience in modelling. They will just create the expeditious model that I need to create right now for this particular function and this particular piece of software I'm building, and then wire it up later. And then the last one is data warehousing, which seemed like a really good idea. Just bring all this data in, conform it, put it in a warehouse, and run analytics on it. This is a really hard thing to explain to actual people in industry. This doesn't work. And people always say to me, look, you can't say that because it's just bullshit because, I'm worked in this company and we got reports and so forth. Well, 80% of these projects are a complete failure. And there's a lot of reasons for that. But fundamentally, I think the human willingness to change or accept commonality and a bunch of other things means that this doesn't work. Anytime you go into any moderate-sized organisation with a data warehouse, you'll find 1 or 2 or 3 definitions of customer and product and proliferation everywhere. I was in a company recently, it took them 2 days for their ETLs to execute to bring in a new customer record from 5 systems. It's just basically a train wreck, complete train wreck. But the other big problem with it, it's inherently very complex. Again, there's no schema agreement. You go into companies and you say, I've done strategy work with them, you say, well, tell me about your analytics. And they go, oh my God, we have a 30-minute meeting about this one thing we need to agree. And 28 minutes is arguing about the definition of it because we cannot agree and the data is all different. 28 minutes of 30 minutes. And this is all senior executives, so that's just a colossal waste of time and money. Data lakes, in theory, solve some of these problems, but this whole thing about schema on read and schema on write that data lakes do, it's a red herring. Mostly it just pushes the problem downstream into the analysts and the data scientists who have to do the work. I saw a stat the other day, 80% of a data scientist's job is data prep, which is just silly, manual work, and 80% of data scientists leave in the first year for another job, probably because they're doing 80% silly stuff. So with all those problems, and that's a lot, and this continual evolution in tech, we should be asking ourselves, why do we keep making this mistake in industry? How can we move that ecology forward in any kind of meaningful way? My belief is that historic focus is the problem. It's blinded us to an essential truth about what we're doing. And I'll use another parable, which is the parable of the bank, to talk about this. We all hate banks, right? So one day I was driving along and my partner, she's an artist, and she said to me, can you explain to me with an example what you're actually doing? Because it's pretty hard to understand. And that's a really dangerous thing because that starts to pull all my brain in to go, oh God, how do I make this explicable to an artist? So I'm driving along trying not to have an accident. And I said, you know what? She said, just give me a good example, something mundane. I said, it's like a bank. So we've been with our bank for 26 years, which is quite horrendous when you think about it. And I said, think about when we started with that bank. What has changed over time in that relationship? People in the role descriptions have pretty much all changed. You don't even have a teller per se anymore. You have a, whatever they call them. All the processes are radically different. The technology stack for our bank has had 2 major revisions, which is hundreds of millions of dollars of change. The people in the roles have changed, applications changed, processes changed, org structures changed. All of the things that you think about from an enterprise architecture point of view have changed, except the data. That is the single bright golden thread over time. You could find us 26 years ago. It's really pretty much all the same thing. So we think from 68 to 2018, if you want to use this as an example, all this stuff has changed. We just had branches, tellers, and cash. Look what we've got now. We've got blockchain and mobile apps and all sorts of things. We don't even go into a branch if we can help it. Checks have gone. If you have a knowledge-centric view, I say data, but I'm falling into the trap of industry, data, information, knowledge, use them interchangeably. But if we think about the knowledge, the only thing that is of lasting value to that organisation, a customer, an account, rates, balances, credit scoring, those are the only things that matter. Everything else is noise around the edges. It's a delivery mechanism at the end of the day. Now, it's funny, when you talk about this and you say this to people in industry, they get it and they say that makes perfect sense, but we don't do it. We can't even say what is data and information and knowledge in industry. That essential truth about the one thing that is of persistent value to a business is almost totally lost to the business community. So I'll just segue quickly, probably going to run out of time if I'm not careful, into the business world now. So this is Alex Osterwald's business model canvas, and it's around about the year 2000, probably because of the dot-com crash. Businesses started to actually sort of ask themselves more fundamental questions. What is the model whereby I operate? How do I take what I have that's unique, bring it into a market, do all the stuff I need to do, marshal all my resources and my people to deliver something that I can sell that has value to a customer? It's pretty much the fundamental kind of operating way for that business. That's actually probably the most well-known business model framework. Prior to that time, pretty much the unwritten assumption in business was that you have a static operating model, business model. You have this transactional model, I make something, I put it out there and I sell it, and you all go and buy it and everyone's happy, and then I kind of forget about it. But unfortunately, the world's quite a different thing now, and technology has accelerated this. So this is showing the evolution of how a customer thinks about what they want out of a business. It used to be in the old days, actually, that you would go and buy flour and you would go home and you would turn that into bread, for example. And the mills, the flour mills, had all the power, the economic power in the value chain. And of course, over time, that just doesn't make sense. You know, people get busier, life changes, things evolve. Then you go and buy flour from, you buy bread from the shop, for example. And then it moved further on, and then you buy a sandwich. But what I'm trying to illustrate here is that the world has changed so much now, and consumers have so much power, so much access to information about products and services, and they are so time poor that actually it's moved away from a product and a service into a solution or an experience. And this is becoming colossally important. I got an Uber here this morning. The experience of an Uber versus the traditional cab is night and day. So the changing demands for the consumer in this place, and they're influenced not just by their own world, like I'm time poor and I've got a family and I've got to do whatever. They're actually also increasingly influenced more and more by government and the social networks in the community around them. So this is very holistic thinking required to think this stuff through. For businesses, if they don't think this stuff through, if they don't change their business model, they literally go out of business. So here's a real-world example of this particular change I'm talking about from a business point of view. This is a customer that Meaningful is working with right now. They're in the flooring, retail and wholesale business. So, in the old world view, before they started working with us, very much it's a sort of a physical thing, a product-driven mindset. I sell, I forget, effectively. So if you think about their data, it's pretty small. It's point of sale. It's very transactional business. I ship something, I sell it, I kind of forget about it. A lot of manual processes, low level of automation, and very, very reactive business. And most of their data is coming out of their ERP system, which is this god-awful thing called RFMS. And those of you into database design would literally have a cow if you saw this. It's the world's worst database. No foreign keys, for example. So they're going through this transformation process, knowing that consumer demands are paramount now. So what they're really focused on now is the consumer experience, not just selling a product, but actually automating everything so you can get all the information you need to be able to put it in front of the consumer so they can make a decision. Massively increased data domain, pulling data from all of these different apps, and we're adding to that all the time. And really trying to craft an experience where eventually in your home you can just scan the floor with an iPhone or whatever, and it will go, well, roughly it's this amount of floor area, and then you can just swipe through carpet samples. Oh, that looks pretty good. And then hit for a quote, you get a quote, and then it can arrange everything. So all of those processes where go out, come back, are you there? Or, I have to be there for this person to arrive to measure my floor. All of that can go away. And it's just this beautiful experience so that it's easy for you as a consumer. And the businesses that don't do this will go out of business, and business community knows that. If we just take that up a level, we can abstract this out a bit, and we can actually ask ourselves an almost ontological question. So with that kind of business change, what do businesses actually need to start doing? What do they really need from us as technologists? They fundamentally need agility. You have to be able to change really rapidly. They need to lower the marginal cost, just like, for example, Uber, provisioning a new rider or a new car or a new driver. It's a trivial thing. It costs them almost nothing to do. Provisioning a new ride or getting a new customer is a trivial thing. Download an app, put a credit card in and go. So they're lowering the cost and the friction of doing that. That's really, really important. But when you're in this agile world where everything is changing, you have to have a persistent, valuable asset base to build on. You've got to have one sort of rock-solid truth, or you can't have everything up for grabs. You've got to anchor your change on something. So what does that mean from a technology point of view? If you look at the other side of the thing, they still need stuff to do things with. They've got processes they have to execute. They have to be able to get things out there. You have to physically do things or action things in some way. And that's really the domain of apps, we think, in the modern world. You do need, I've railed against the application-centric mindset. You still need tools. You still need applications. They need to be able to analyse what's going on, and this is really, really important. But not just most analytics is either pull a tiny subset of data and subject it to the squeezing process and then create something out the back of that. You actually need the whole data set. You don't just need, I've got this product and I've sold this. You actually need the experience. What is a customer saying about you online even? Completely outside your data domain. Can I bring that data in to analyse? Well, maybe the customer said, yeah, that was okay, but actually online they just said it was a really terrible experience. You need all of that to make a holistic view of it. And fundamentally, you need to know what you're doing. You need that bright line, that bright thread of knowledge that survives applications and processes and time and people. You need to have that as a central core of your business, again, to anchor yourself. So if we just jump back to an ecology view now, you could make a colossal slide to do this, but what I've done is I've broken the technology world for business down into three things. There's consumer, the small, medium enterprise, and then enterprise. So enterprise is really big businesses. In New Zealand dollar terms, that's probably 500 million, but globally IBM had a definition that was several billion, but it varies where you are. But basically, really big company, even a small startup all the way up to hundreds of millions of dollars, and then consumer. And what you can do is you can look at, this is an overlay, and you could make more and more and more of these, but this is an overlay of information management products that are designed to address some of the issues that business have. So you can see there's quite a lot in the enterprise world, things that do integration, that do analytics, that do all of the things I talked about before, service design and so forth. Consumers are very well served. We have apps, we have mobile phones. It's a really great world there. But in the middle, these small to medium enterprises, they're actually really, really stuffed. The economics of creating technology in that space there to do those sorts of things stop you selling into the SME market, because the cost to build and the cost to sell is so high, the SME market cannot afford what you build. And we see that with our customers that we're dealing with at the moment. Probably the cheapest integration platform is Dell Boomi, and that starts at about $200,000 a year, which is unaffordable in New Zealand, and probably most countries in the world, for an SME-type client. You also see that a lot of those enterprise solutions are not changing very much. They are iterations and evolutions of the same thing going on and on. I put Domo up there. Domo is a really interesting product. I mentioned that industries walked away from data modeling. Domo's got this really nice way of pulling data in, like ETL, and it generates these really great dashboards, and then in the middle is no model. So every time, if Jill wants to look at customer and I want to look at customer, we have to create our own definition of customer, and hopefully they're the same definition, but they probably aren't. So there's no model in between. And it's what people are finding with that product, well, hang on, we just created all this analysis and it doesn't match. So they basically keep reinventing the wheel in that particular space. But that SME market, they have a really hard time because they've got a lot of the same needs as that enterprise market. They need to be able to integrate things, analyse them and so forth, and they just can't afford those sort of those enterprise scale solutions. But also their data needs are proliferating. They're needing to pull information from all sorts of sources. The weather, lots of businesses need weather data, for example, and pretty much you have to subscribe to an API integration platform to start doing that. It's just too expensive. So if I had to summarise it, I'd say that, in particular, we're dealing a lot with small and medium businesses. They just actually don't know where to start. It's a really real problem for this size of client. They just don't know what questions to ask. They don't know who to ask. They can't afford it. If they've got some knowledge, it pretty much leads them down a rabbit hole, and then they end up in that project hell that we talked about, where things don't work. And they just see this complex ecosystem, really high costs, massive diversity. If they do know anything about technology, they actually kind of understand that stuff doesn't work and that there's really low success rates. And all this complicated stuff has to come together before they get any value out the end. Given that the business people are the ones that sign the checks, I've just said checks have gone away, but basically this is a completely foreign language to them. It's pretty incomprehensible, and their default position is to do nothing because that's the safest thing to do. So how do we find a way out of that mess? So if I go back to that bank parable again, I believe that the answer is in knowledge. There's nothing in the market that actually deals with that. Because of the history and the mindset of us as technologists, that what we're dealing with, this whole legacy world, this process and application-centric mindset, there's really nothing that exists to think about it like that particular way, that knowledge is that bright line that we should all be managing. We just end up with data in silos. It's really hard to extract. It doesn't play nicely at the whole enterprise level. We can't get hold of a view of what's going on. Context for decisions is missing. This is a big criticism of analytics. I got this value back. What is the context of it? I don't understand the context of a result. This is why we need semantics in the business community. It's why it's so crucial to get the meaning into that data from all of those applications that we're putting in there. It's not just that the business and tech have to come together. They've got to come together around shared meaning, and that's the thing that's missing. If you do that, everything else in business computing is epically easier. And, really, realistically, so far the only technology stack instead of standards that's ever been created that deals with knowledge is the semantic web stack. It's just really the only thing that we have that can be explicit about knowledge. I particularly like that explicitness. You can take a concept in a CEO's head and represent it in a triple store, and you can find that. If you want to, you can let them even look at it, and you can't do that with other technologies. It's just so much different to our traditional technology landscape. Once we get that explicit knowledge into business, then you can actually move forward to crafting those kinds of experiences that customers actually want and serve real needs, and instead of just throwing products and services out there and hoping that there's something that a customer wants. So that actually means that you have to encode knowledge directly into the business model. The business model has to become the schema for that business. It has to be driven from that knowledge model. And that, in turn, will actually drive all of the technology that you cohere, bring to bear on that business, and how you actually operate that business as well. So there's a lot of stuff that has to come together to do that. We think also it actually requires a fundamental reinvention of enterprise computing, and that's a big ask. And the point of that is to actually serve every business, not just those enterprise-scale businesses, but to drive it all the way down company sizes so any company that starts can access knowledge-centric technology to build a business, operate a business, and change a business as they go. It should be like your iPhone is a personal operating system for you. You can do what you like with it. When you delete an app that's uses address data, it doesn't delete all your address data. It's always there for you. These things come and go, but the core data remains. It should be the same in business. There should be a business operating system that lets you loosely aggregate this cluster of federated applications and analyze all the data, and things come and go. Processes change. That's what apps are for. Change your process, throw that one away, get another one. It's quite interesting, actually, when you study that. We talk about this quite regularly with customers. A year ago, there's various sites that track the number of SaaS applications. About a year ago, there were 560. I looked last night. There are now 700 categories of SaaS applications, and some of them are so micro-vertical. How to manage a swimming pool. It's taken, instead of making these massive ERPs that do everything, it's like, here's a vertical thing that someone's got a problem with. We'll just look at those processes. We'll build one thing for that. If you don't like it, flip it out, get another one. Very, very agile. But we need to, in that world, turn it into, just like an iPhone, like a personal operating system. So over the past 3 years, Meaningful, my company, has actually been building out an architecture to do this, fundamentally driven around the needs of integration, analytics, and governance. It's built on top of Neptune, which is a great triple store, and we fully subscribe to all the major semantic web standards. And we're quite close to actually creating a beta release of this platform. Our experience with clients is that when you do this work with them, you can completely shift the mindset away from process and application centricity to knowledge. It actually does work with them. And it's really great because it helps them get out of a lot of really sticky problems. I'm working with a company with 3 enterprise resource planning systems, so 3 monolithic, horrendously expensive things that they actually have to get rid of because 2 of them are completely out of date and unsupported. And this is really the only stack I've ever found, the only set of technologies where you can slowly ring-fence these things and then get rid of them one at a time. So we think that this knowledge-first semantic approach to business technology really is uniquely suited to helping these businesses evolve, both in terms of getting rid of that old stuff, but actually moving into that modern business world that I talked about. So that we as business people can create what actually customers need to exist out there. And fundamentally, it's very, very different too because it avoids all those technology mistakes of the past. So there's quite a long way for us to go in building out this architecture and prove it out, but I just wanted to sort of put this out there that there's a few things that we don't know how to do, and we're partly an R&D company as well as a product company, but I would just put out to all of you here and the great research that you all do, and I've read a lot of your research over the years. There's a few things that we really care about in terms of what we need to build out over time. Entity resolution is a really important thing. Really large-scale visualization. It's a very, very difficult thing to do. We've made some progress in that, but we'd like to get to a point where find your path through the data, that kind of instance-level discovery is just very, very easy to do, but you get very large corpuses of instance data with not massively large ontologies, but it becomes really problematic. The 3rd and 4th points, I think, actually could be merged together. There's a real, I think, utility in having a no-code or a low-code semantic-driven, model-driven development type environment. I think that would be massively useful to industry. If you have a comprehensive knowledge model of a business, and you evolve that going forward, you should be able to build, in a model-driven development sense, you should be able to build low or no-code solutions off that. This low and no-code is becoming a big thing in industry now, and I think Semantics could step in there and provide something completely unique. There's always IoT, that's going to be a big thing. Transaction support, standardized transaction support for Sparkle, like an agreed standard. Horizontally scalable triple stores. And along with that, actually, one thing we're going to move into eventually is very, very large customer base, we hope, and we would like to be able to have multi-tenant partitioning and graphs, which will come, I suppose. Performant real-time reasoning as well. There's a lot we can do with reasoning, but it's just not performant enough at the moment. It's always a problem. So those are just some sort of pleas out there to you as a great community, doing great work. And finally, I'd just like to take a moment to thank Dave McComb from Semantic Arts. These are a couple of his superb books, which I'm trying to force on everybody in the business community that I come across. Software Wasteland and the Data-Centric Revolution. So Dave has perhaps done more than anybody else in the business and technology community to try and highlight some of these issues I've been talking about. When I started working with semantics and uncovering these problems, that was around about 2008 when I was at IBM. And it really seemed like nobody in the business community was wanting to even think about this or deal with it or even understand the problem existed. And then I actually found Dave's writings around about 2017, 2018, and for me it was just fantastic to see that somebody else was out there. In fact, Dave's actually created this thing called the Data-Centric Manifesto. He's probably used the word data because business people don't like the word ontology. They feel threatened by it. And that's actually gaining real traction out there. So it's not all just me saying this. There is actually a movement out there that's saying that we need to bake knowledge into business now. And they also, Dave has founded Semantic Arts. They've created GIST, which is an upper ontology for business, which we use as well, which is really good ontology for business. So a big thanks to Dave for doing one for the team there. So, so that's me. Thank you.
Thank you very much, Dougal. I think you've given us quite a lot to think about, and it's provided a very good context for the research talks that are coming up later in the conference. So we've still got about 10 minutes for questions. So does anyone have any questions of Dougal?
Daniel Schreiber from the Catholic University of Rio de Janeiro.
Daniel, the mic is coming.
Hi, Daniel Schreiber from the Catholic University in Rio de Janeiro. I'd like to ask you to say a few words about how do we take factor in privacy concerns in your view of the architecture.
So, so that's a fantastic question, and it's a really difficult thing. This is another problem that's not served well by the business tech community. So I saw a survey the other day from Talend, and Talend is a company that makes a whole bunch of data management products, and they have a bunch of stuff around governance. And they did a very practical piece of research across Europe where they went to 100 companies that advertised that they were compliant with GDPR, and 30% of them actually had any kind of level of, I can produce a report, so that just I can't remember which article is, Article 11 or something. So very, very low levels of compliance. Our industry treats that GDPR and the Californian and the Brazilian laws that are following as a burden, a regulatory burden, which is ludicrous. So there's an attitude in industry that, your data is my data, and it's kind of screw you, actually, which is terrible. So I think with knowledge-centric computing, providing you have enough provenance data about what you've done when you've ingested data, you can actually generate privacy-compliant systems almost for free. So at the moment in our platform, when we ingest any data, we keep a bunch of provenance triples about that data and metadata on it. And we're going to build out in next year a suite of stuff for privacy compliance, because it's quite easy to ask the triple store, tell me everything about Dougal, and I can find not just what's in the corpus, but actually what it came from and when it came. And with modern REST APIs, there's a relatively high chance you can do, for some things, actually delete, if they want to be forgotten, you can actually delete the source data as well. So I don't think of it as I think of it as a human right that everybody should follow and just by right. And I don't see it as being technically complicated, but because of that application-centric mindset that is pervasive in industry, you have no control over those massive volumes of data, and it's just become too difficult to manage practically. And that's partly why industry kicks back, because they know that on one level. If you have to go into a data warehouse and then you find 3 definitions of customer that don't agree, good luck trying to find which is the right one and how you're going to delete it if that person wants to be forgotten. But it should be complied with. It should be absolutely baked into everything that companies do. Hope that sort of addresses it.
Any other questions?
Douglas, I was wondering if you saw any. Douglas, I was wondering if you saw any inherent conflict between the comments that you made about agility, and as both the size of ontologies and the number of ontologies actually itself becomes larger and larger, do in fact we just really circle back and end up with a whole series of problems to do with data modelling and also EDW?
Yeah, that's a really good point. We have thought a lot about that. One of the reasons we use GIST is that it's super interesting in how it forces a particular discipline around modelling and about thinking about fundamentals. And so I'm the technology director, but I've got a business director as well, and he's a turnaround CEO, and he has done a lot of analysis of structurally what is different about business. So he's kind of, from an ontological point of view, he's a bit of an abstractionist as well. And it turns out that I think I think there's actually only about 13, if you distill it right down, there's only about 13 different classifications of what businesses do. And you can actually do this massive ontological reduction of that complexity. It's not so much that businesses are all radically different across the spectrum. They're actually not that different. What is different is the way in which they engage with customers and how they put themselves out there. It's sort of things around the margin of the core of what they do. So we believe that creating an ontology that might only end up being 300 or 400 classes, you can effectively reduce a colossal amount of that complexity, which actually makes agility much, much easier. And we're testing that with customers who ask the same question. And so one example is from a financial management point of view, like if I give you my chart of accounts in a large company, there'll be hundreds of categories of things in that. Well, actually, if you analyse that, it's a taxonomy. It's not an ontology. And all we need to do, and this is where natural language comes in, all we need to do is ingest that as a taxonomy, embed it within the right class structure, possibly do some kind of NLP on the names of, if account number 1000100 is employee wages, for this part of the manufacturing business, this division, we can actually reason on that. Well, we can pull out there's an employee and there's wage and there's a cost. We know that the ontology says that's a cost. We can actually link that sideways into the ontology in several places. So we have taxonomic complexity reduced into ontological simplicity. And when you explain that to a business person, not quite in that language, they go, oh, wow, God, that's just incredible because that's brilliant. I mean, just mix and match. So, yeah, again, it's industry's walked away from modelling, but our company has not walked away from modelling. It's a prerequisite. We call ourselves, we said that the thing you need to have here is you have to be an abstractionist to work at our company. It's crucially important to be able to model really, really well. But yeah, it's a risk, and it has to be, it's like a kind of a discipline that we have to have the whole time, not to proliferate complexity. We need an app for route optimization.
Yeah, thanks. Pedro Zackley from the Information Sciences Institute at the University of Southern California. So I was struck by the beginning and the end of your talk. This whole chart for the future seemed to me like a sort of database kind of work. And at the beginning, you had the table, and you showed us a table with pictures. And we don't actually know how to represent a table semantically. If I look it up in the Wikipedia, it says it's an instance of thing.
That's not very helpful, is it?
And that's it. And it has a natural language definition. So you think that, so what is the role of semantics understanding our everyday objects like table in a way that say, when I tell my helpful robot at home to put the coffee on the table, it actually understands what I'm talking about.
Yeah, it's quite a fundamental question. Table was a really difficult one. That's probably why I chose it for that parable. This is slightly the difference between an ontological question and a business question. In a business community, But beyond a certain point, the fundamental distinct difference about that doesn't actually matter. The distinction matters in terms of what you can do with it and how you can manipulate it more from a business point of view. Table's not a good one. I can switch to things like manufacturing. So we have a bunch of stuff in our ontology around how you conceive of the physicality of manufacturing. And the physicality is manifest in some, it's an interesting modelling distinction. You work between this physical world and this virtual world, or this abstract world. So the abstract world is, you walk in the door, like you go to the address for this factory. There's one address, and it's a really big physical site. And so you go onto it. The thing is a site, which is really just virtual. It's a logical construct. Within that site, you might have one or more plants. And a plant is a physical thing, and it's physical to the company because machinery lives in there. There are rooms and buildings. People have work centres where they work at. So they're all physical locations and material physical things that you can define ontologically. Like you can define a building ontologically. It's defined in GIST. You can define geospatial coordinates for all of those things. You can define work centre as a virtual construct, but it's temporally bound to something physical. And then you can trace the physical goods, like the raw materials that come in. They come into a loading dock, which is a physical location. You can describe structurally the nature of that physical good, the units of measure, the chemical composition, if you like to get it down to that granular level. And you can describe how it moves through all of these stages, again, through temporal relations bound to physical locations, till eventually it creates, through one or more processes, manufacturing processes, defined by a bill of materials, which you can define ontologically, to make something physical. But actually, like if they make a table in that sense, what they really care about is more how that table is distinct from other products, and how it has attributes that can be used to put it out there and so that customers know what they're buying, that it can be managed at an inventory level, at a stock level, and so forth. So we actually have to be quite careful about not getting too ontologically precise necessarily about some things, because you can never finish. I mean, there is literally, like data, information, knowledge, it's one of those things that's actually not possible, I think, to define accurately enough to make the distinction between them. Some things are like that inherently, but as long as we have enough sort of knowledge resolution to do actual work, the doing, which I talked about before, that's okay from our point of view. Slight difference between the communities, I think.
Yes, Jonas Almeida, National Cancer Institute of the NIH. So I was trying to understand your data-driven design while comparing with process-driven and application-driven in the context of the data manifesto, data-centric manifesto. So if I understand it well, this will also push the data modeling towards a primary concern with governance rather than the semantic that contextualize it. Did I get that right?
No. So we have an ontology, a business ontology, and it has just as its upper ontology, and then we're fleshing that out with various constructs that are required, but it is a general ontology for business. Now, there might be some things that we choose not to deal with from our point of view, but I can't think of any, but you could imagine some weirdo thing that is just too complicated to model. But generally speaking, it's a universal model, and this is yet to be proven. I mean, I might be risking the entire company on something that's infeasible, but I think it is, given our understanding of the structure and nature and form of business and the things that businesses do, we believe it's possible to model all of those 13 categories in one ontology. The governance stuff just comes for free if you have enough metadata about provenance, enough provenance metadata that you pull through. And the governance thing, to my mind, is a very, very important thing for the privacy reasons that we talked about before, that it's not our data. It's not our company's data. It's actually your data at the end of the day as people that consume these products and services and experiences. But so our drive in our business is that schema, that ontology, is the definition of the business, fundamentally. And the business doesn't have to worry about data modeling and which thing to choose, which package to buy, because they'll all work. And we actually have a demonstrator working now, zero code integration. We can point our technology at any endpoint and pull the data in and conform it. We don't have to write code for doing that. And we've tested it with a bunch of apps, and it works really well. Eventually, it needs machine learning to remove there's a human element in there. But the point of that is to say that the business doesn't have to worry about modeling now. The business worries about creating those unique experiences, because it's just too much. Like the company I mentioned before, They bought another company. They're going through this wrenching change to integrate this other business. It's a business change problem, not a technology change one to start with. They don't want to have to think about all of this complexity. It should be taken away from them, just like an iPhone. On an iPhone, you don't go, my God, I'll do a deep analysis of which app to buy. You just download it, try it. If you don't like it, you turn it off, delete it. In our world, if you have a customer management system and you're using it one day and you don't like it, you want a better one, you just turn it on in our interface. The data flows automatically because we know the producer and consumer relationships per class, and then you turn the old one off, and that's all you need to do. You don't have to, and if you don't like that one, do it again until you're satisfied. That's how business computing should be.
Okay, so we've got time for 2 quick questions, one here and one up there.
Hi, so I'm Juan Sequeira from data.world. We're in a room full of academics, educators. So you please tell the audience, what should we be teaching the students nowadays? You've been talking a lot about data modeling and stuff. Like, you want to go higher, you want to grow this industry. What are people missing? The next generation coming out, and what should we be teaching?
Yeah, that's a really hard one. I mean, I've got kids, and they'll eventually go to university, and I think about that a lot actually. And I engage quite a bit with the computer science department here at Auckland, and we do some really good stuff. And they do some great teaching. I think a diversity perspective is the single biggest thing, actually. It's the thing that's most lacking. I've had so much resistance to these ideas from technology professionals. And when you come out of, when you're at university, you should be open, and most people are really open to the world. They're open to new ideas, and it's just broadening that perspective. Like, the study of informatics or information systems at universities is pretty much application centricity and process centricity, in my view. And just broadening that again, just taking it to a more holistic view, more than anything else, is probably the single biggest thing that could be done. Because you still need to learn all that other stuff. I'm not saying that other stuff is invalid. It's entirely valid. We still need relational databases. We need apps. We in many ways, we kind of need data warehouses as well. But we need that broad perspective to say that's not enough. And the computer science at Auckland's doing quite a bit around educating people around things like semantics as well. And I just think that sort of stuff should be broadened out. But the kind of perspectives I talk about here from a completely outsider view, like psychology and history, that's really important as well. That's the interesting thing when you learn psychology is they hammer the history of it home to you. These mistakes were made in the past. This was not enough. You need to think more about that. Galen's 4 humours theory is just ridiculous, and we grew our understanding over time, and we still not, we don't have a full understanding. That is gold. That is probably more than anything else that people should learn. That's part of learning how to learn, is that you don't know everything, and there's a very broad world out there. And I just wish more technology professionals had that. The single biggest thing we have hiring, the biggest problem, a technology professional, the junior ones, we've hired 2 recently, they are so open to this because they don't know that that's not the way to do things. And then there's a middle tier, who have they've got a lot, relatively 10, 15, maybe 20 years career. They are closed. They're like closed world. Their mindset is closed world. And then you get the 20s plus people, the really good ones that can data model, and they have failed in things, and they've seen why it fails, and they are ready to open their minds and say, do you know what, that was all crap, it didn't work, but I'm willing to understand that, because I know things don't work. I know that, this big project, I worked on that for 4 years, and it was canned for these reasons. So it's quite an interesting thing. So that perspective is the most important thing.
Hi, Dougal. Thank you for a fascinating talk. My name's Melinda Hodquist. I'm from Perth, Australia. And I just wanted to support something you said around the need for business ontologies. Maybe of interest to people that in February last year, more than 43 companies and 28 research institutions went to Norway to talk about industrial ontologies. This is an open source reference models, kind of like you're saying, for specific, repeatable engineering and maintenance transactions. How do I do logistics? How do I do production scheduling? How do I do maintenance? So very much in line with what you're saying. And I just wondered if you were aware, and that's out of the engineering and maintenance community, something called the Industrial Ontology Foundry. And there are a number of people who were at that meeting here in the audience. James Ian Horrocks, if he's around, if people are interested in this. Are you aware of this sort of bottom-up movement around open source ontologies in any other sectors?
The only other one that readily springs to mind is probably FIBO for the financial industry, but that's very, very complicated. The GIST guys are probably going to release a cut-down, massively simplified financial ontology soon, but that's a really big thing. FIBO is actually not too bad. So yeah, in financial services, it's a big thing.
Yeah, we're working with the FIBO. We're trying to learn their back processes in order to manage our industrial ontology foundry community as well. So we're connected with them.
I suggest then, tracking what the GIST guys do when they release that. I mean, they're doing a deep refactor on it at the moment, but so far it actually looks very interesting what they're doing. It's actually very, very difficult as a business technologist to get a good ontology that can be used in a business context. Luckily, Shapes Shackle is just such a fantastic thing because firstly, you can argue with technologists and go, do you know what, you can have constraints on your triple store if you want, so that then the whole relational kind of mindset can be satisfied. But we are doing a lot of work with Shapes in terms of subsetting views on the triple store. And it's massively useful for doing a kind of complexity reduction to show end users, like if you have a temporal relation in your ontology, you don't want to expose that to a customer. They kind of can't get it because they're not abstract modelers. So you can collapse it all down through a shape or set of shape definitions. It's fantastic. So yeah, but there is a real need for better, more comprehensive, simplified business ontologies.
And we are also aligning them to an upper ontology with the idea that they will be interoperable as well. So I think that's also maybe a controversial but an interesting development.
And I think that the reason we chose GIST, because I did a survey of all upper ontologies, and by far most of them are vastly too complicated for business. GIST has only got, I think, 13, 16 primitives, I can't remember, 18 primitives. So yeah.
Okay, we have to move on.
Cool, thank you all.
So thank you very much once again.